This video is for the velocity as a vector data collection. So we need three distance measurements where I have this little weight here, and right here where the rulers come together, that's where my black marks were that we saw in the velocity as a vector execution video. So I'm going to measure from this black mark down to where I hit this line, the crack that runs straight from the same direction as the piece of tape here. So this is my vertical distance. This is my x sub y distance, and then I'll measure the distance. And you obviously don't have to have this many yardsticks, but this just visualizes what you need to do. So this should be a right angle. So my y distance, my x sub y distance, is from where it crossed. You can actually kind of see the black mark there if I don't cover it up with a copy, where the tires crossed there to where this crack that runs straight from where I started, and then from the perpendicular distance I go straight down here, and then where this crosses perpendicularly from where I crossed here, I measure my x distance this way. So I'm making a right triangle. And then I will also need to measure, I have a string here, you can just barely see it, you may not be able to see it in the video, but I have a string from where I crossed here to here, so I can make sure and get a straight line distance, and I need that distance. That's my x sub d distance. The other thing I need is that angle. So here's that string I was talking about. Here's the mark I made when the tire crossed. So I measure the angle between my horizontal direction and the direction that the car actually went, and my angle would be about 30 degrees. Last piece of data I need, the order you collect it obviously doesn't matter, but the other piece of data I need is the time, and the time we're talking about is the time it takes from when I cross this line. That's the horizontal distance in my triangle. So I would measure that time, which in my case looks like 17.15, and then I would measure it until it hits the line there, which looks like it's about 26.25. Actually, it's probably closer to 26.35. But anyway, everybody knows how to do that. So you measure the time from where the dune buggy tire hits here and hits here as accurately as it can. And that's all the data you need for the velocity as a vector activity.